Okay, let's look at 4.2. Again, this is still a data handling question, but slightly different view from 4.1. So here it says table 3 below shows the number and percentage of children from 3 age groups who did not attend any South African educational institution from 2002 to 2009. So it doesn't say why they don't attend, and that's not actually the point of this. This is more saying, let's go and look through this data and see what it's saying, okay? Numbers and percentages of children not attending any SA educational institution. Okay, that's just the title. Here's the 3 groups of people, so 7 to 15, 16 to 18, and then 7 to 18. So what you should see is that this group plus this group equals this group, okay? Right? You should be able to see that, okay? So this group here is just a summary view of those two. Let's now look at the questions. So you could be saying, oh, but what's going on in this table? You don't need to understand everything up front, right? You can go look here, look at the number of children, percentage. You could be saying, oh, what's going on? Remember, the questions help us understand what is required. So let's go and see what is being asked for. So table 3, we can use the table 3 to answer the questions. So it says, firstly, it says, state why the data for the number of children is regarded as discrete. Now, remember, there's 2 types of data, discrete and continuous. Discrete means that it can only be a specific number, like 1, 2, 3, 4, 5. For example, what grade are you in? You're either in 11 or 12. You cannot be in grade 11 and a half, right? So this is what we call discrete. Then when we get to continuous data, it's saying you can be anything in a interval. For example, I could say, how much do you weigh? Now you could weigh 75 kgs or 75.1 kgs. Do you see how it can be anything in an interval? So it's allowing for those decimal places, whereas that's not generally the case in the discrete setting. So here you should be able to see, actually it's going to be a discrete data set, right? Why? Because you can't have part children. You either are a full human or you're not a human, right? And that's just how it works. There's nothing in between. There's no fractional people, okay? So we know for 4.2.1, we are going to say it's discrete. Now, it just says state, so you don't have to now go write a whole blurb as to why it's discrete. It's just discrete, and we leave it at that, okay? Oh, I didn't read the question properly. It says state why the number of children are discrete, so don't leave it like that. My bad. You have to say number, that's just shorthand for it, number of children, right, cannot be fractions. Okay, so that was a lesson in reading your question properly. Okay, let's look at the next one. 4.2.2, identify the age group where the majority of children did not attend any educational institution. So if you look here, the age group is either that, or this, right? You can see from the percentages, and even just from the number of children, that the age group is going to be 16 to 18. This is where a lot of people are not attending school, right? This should make sense to you in the sense that people drop out often after grade 9, right? And so that's a space where they are often getting jobs, etc. Not always by choice, but that is often where they will move out of educational institutions. They generally stay at earlier stages, okay? So it's 16 to 18. Perfect. Let's now look here. It says, give the year during which the age group 16 to 18 showed the best attendance. Okay, now be careful here. What does this show? This shows the number of people that aren't attending. So the higher the number here, the worse it is. The lower the number, it actually means more and more people are in institutions, and that's fabulous. So we're looking for the lowest percentage. So here is actually the best, right? Let me just use a highlighter so that you can see, right? There's actually the year where it was the best, because we have the lowest percentage of people and the lowest number of children that are outside of the schooling system. So we're going to say 2007. This is one that students often get wrong because they'll choose the one that has the highest. So they'll say this one, so 2002. That's actually the year with the worst attendance, right? So be careful that you understand the data that's being presented to you. Let's now look at 4.2.4. It says determine the missing value of A. Okay, so we know when we saw this that they were going to ask us to find these values, right? They never put these A's and B's in as missing values unless we have to calculate them. So we knew that was coming. Let's just see what A is, okay? If we look at the other spaces, we can see, as I said, that this plus this gives me this. So if I want to get A, right, I'm likely to be taking that plus that, and that will give me A. That's how it's done in all the other age groups, right, across the other years. Now you could be saying, but Margie, what about these percentages? There's this 3.7 plus 17,6 doesn't give me 7. Like, what's going on here? You're right. So don't stress. You're right there when it comes to percentages, right? Why is that? Because we're saying, well, here, this 3,7 is saying, well, 3,7 of the children that are in this age group don't go to school. Okay, here we say 17,6% of this number of children don't go to school. Here it's different because you're combining them and you're saying, well, how much of the total number of children don't go, right? And it gives a slightly different lens because the mix of these children that are 16 to 18 or 7 to 15 is different to the mix that's over there. Now you could be saying, Mark, I don't know what you're saying. We'll get there. Don't stress. The next question gives us a bit more context. But for A, it's just adding these absolute amounts. We don't care about the percentages. A is not a percentage. A is the number of children. So we just add those two together. So we say 209, 309 plus 539, 177. Okay, so you add those two together. Biggest thing here is that you put it into your calculator correctly. Very easy to do incorrectly. I seem to be like a walking hazard when it comes to inputting numbers into my calculator, but there we go. So that is our answer, 748,486. There's your answer. Wonderful. And we are moving on. Okay, we almost finished this question. Right, let's look here. It says, determine the missing value B. Now this is a little bit trickier because we can see that B is a percentage. Okay, if the total number of children in that age group was 9281000 in 2008. Okay, so it's basically saying the total number of children was this in the 7 to 15 age group in 2008. Of those 9281000, right, this is the number of children that were not going to school. So we're basically saying the number that are not going to school is this. That's what the numbers are saying. That fraction of that total amount. Okay, now we want to get it into a percentage because that's what's being written in that column. So to get it into percentage, we have to times it by 100. You put it into your calculator. Again, don't be a hazard like me, right? 194,901, 9281,000. Oh, make sure that you put the right number of zeros. And your answer is 2.1%. Okay, so 2.1% of the children in this age group, right, in 2008 were not going to school. Kind of makes sense if you look at the other percentages, right? So kind of seems like it's in the right ballpark. If we were getting like 25%, then you're like, red flag, like we've done something wrong, right? So just always like check it against the rest of the data that's given. Let's now look at the last question. So it says 4.2.6, draw a broken line graph on answer sheet 2. So make sure that you get your answer sheet. I have mine here, right? Always remember when you get this, put in your center number, your examination number, don't mess that up, right? And this is where we're going to fill in everything. So it says, use the answer sheet to represent the percentage of children in the age group 16 to 18 not attending any educational institution from 2002 to 2009. So we're looking at basically this group of people. Okay, and what did it ask for? The percentage. So we're only looking at those percentages there. Okay, so we're looking at these guys here. Oh, that's a little bit messy, but you know what I mean. Okay, so we're going to go and put those in. Okay, right, so our first value in 2002 is 17.6. So there's my middle, there's 17.6, then it goes 17.2, then it goes 17.3, then it goes 17.8, then it goes 17.5, then it goes dip. Everyone will be going to school this year. 14.8. Okay, this is a bit tricky. Okay, you could be saying, how are you doing this, Marks? So you see here that each of these lines represents a 0.1. So to get to 0.8, I go 14.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Go across. Use a ruler if you need to, right? I'm playing with fire here, right? And then here, it's going to be 16.2. Over here, should be 16.7. Okay, now please use a ruler, right? I'm not going to use a ruler, but please use a ruler. Broken line graph, you connect each of these using a ruler, right? So do as I say, not as I do. Connect all of them like that, and then you are done, right? So be careful here. Did it ask us to label it? And let's just see if it asks us to label it. So draw a broken line graph to represent. Didn't say we have to label it, so that's okay. You don't have to label it. Just connect the graph and then you are done. Okay, and that's us done with question 4. We just have question 5 and then we are done. Well done, guys.